Welcome back. In our last video, we explored movement, the concept of force, and how simple machines like pulleys can make moving things easier for us. In this video, we'll continue exploring simple machines and how they can help us move things that we otherwise couldn't move. This week, science moves. Today, we're going to learn about inclined planes, which are also called ramps, and we will see how they can help us move objects from one position to another using less force. This experiment will show you how to make your own ramp, and we will consider different materials to find which surface creates the best ramp. We hope you enjoy our video, and be sure to download resources from the website so that you can follow along at home. You can click here, or you can find a link in the description. When we made a pulley in our last video, our purpose was to lift something straight off the ground. However, sometimes we don't have the materials to make a pulley wheel, or the ability to attach it to a high place. In order to move something to a high position, we may choose instead to use a ramp. Ramps are useful because we can use a force to push or pull an object up a ramp in order to change its position. Because ramps have a long, smooth surface, this allows us to easily move objects across the ramp without needing a lot of force. A ramp can be steep, which means that it rises quickly, or a ramp can be shallow, which means that it rises slowly over a longer distance before reaching the same height. The more shallow the ramp, the less force it takes to move the object. In our daily life, we use ramps in many places when we want to move heavy objects from one height to another, but without lifting them straight up. You can find ramps outside of many buildings since they help people enter without needing to use stairs. This is very helpful for people who may have accessibility needs. Moving trucks also use ramps to make it easier to move boxes and furniture in and out of the truck. To make our own ramp, we will need some books, large sheets of cardboard, an apple, a plastic cup, masking tape, string or floss, and lots of pennies. First, we need to make the surface of our ramp. To do this, cut out two same-size rectangles out of cardboard and tape them together around their edges. This will make our ramp surface stronger. Make sure your table is at least as tall as your ramp is long. You can test this by holding your ramp beside your table legs. To put our ramp together, place some large old books at the edge of a table, and place your cardboard so it rests on the edge of your stack of books. To keep our ramp in place, we will use tape to stick the cardboard to the book. Be careful though, as tape can damage the cover of some books. Since cardboard has a rough surface, we can make our ramp smoother by taping sheets of paper to cover it. Now our ramp is built and ready for us to move things. So how are we going to pull our apple up the ramp? We can make a rope out of dental floss and tape it around our apple and pull on the other end of the floss to pull the apple up the ramp. You can make this easier by using a hair elastic, rubber band, or tape to help edge of the ramp. This means that we need to attach a light plastic cup to the opposite end of our string, just like before. Place your apple on the lower end of your ramp, not on the desk. This prevents the apple from getting caught on the edge of the ramp. Pull your floss up the ramp and let it hang down the side of your stack of books. Pull your floss over the edge until there is about the length of a ruler hanging over the edge. Use your scissors to cut the floss to this length. Finally, push the end of your floss through the holes and tie a knot just like before. Start adding pennies to the cup. When it looks like the floss is pulled tight by the weight of the pennies, begin adding the pennies one by one until eventually your apple is pulled up the entire ramp. Try to catch your apple before it falls over the edge so that your coins don't spill on the floor. Now we can count our pennies to see how much weight it took to pull the apple up the ramp. In our test, it took us 93 pennies to lift the apple. Make sure to record your results on your observation chart. If you did the experiment in our last video and recorded the amount of pennies needed to lift an apple using your pulley, now is the time to compare your results. Did your ramp need fewer pennies than your pulley did? Which simple machine would you use in real life to help you move things? In our experiment, it took us less pennies to lift our apple up the ramp compared to how many pennies we needed when using our pulley. This is because our pulley only changed the direction we were pulling, but the ramp actually lowered the amount of force we needed to move the apple. Some of you at home might not have gotten the same results. Depending on how smooth the surface of your ramp is, it might not have been as good at lowering the amount of force needed to lift your apple. The reason that it might take more pennies to use a ramp is because of something called friction. Friction makes it more difficult to drag an object across another object. Both surfaces pull against each other, making movement slower or even impossible. A crazy example that involves lots of friction is if you took all of the pages of a phone book and laid them across each other, you would have hundreds of pages rubbing against each other, creating friction. If you tried to pull these phone books apart now, it would be almost impossible. In our experiment, the waxy skin of our apple rubbing against the surface of our ramp creates a lot of friction, which makes it more difficult to slide the apple up the ramp. This is why it is important to use a smooth surface when creating your ramp. The smoother your ramp is, the less friction will be created between the apple and the ramp. You can try to change the amount of friction in your experiment by changing your ramp surface. Instead of covering your ramp with paper, you could try using other materials like aluminum foil, cling wrap, or even cover it in a shirt or towel. Compare the amount of pennies needed to lift your apple, depending on what material you use to cover the surface of your ramp. We challenge you to try a couple different materials at home and find which surface makes the best kind of ramp. You can keep track of your experiment results by using the observation chart from our website, which you can find in the video description. So today, we learned about another simple machine called the inclined plane, otherwise known as a ramp, and explored how ramps make our lives easier. We also built our own ramp and learned how friction can affect how effective a ramp is at moving objects with low amounts of force. We hope you tested out different materials at home and compared your results. If you found a great material to build your ramp with, let us know in the comments or tag us online with our hashtag, ScienceCityAtHome. We hope that you enjoyed our new video, Science Moves, from our new series, Science. And stay tuned for upcoming videos where we'll show you more experiments to do at home. Until next time, keep exploring.